In the annals of aviation, some stories blur the line between daring flight and unintended voyages into the cosmos. 1963. A rocket-powered aircraft, the North American X-15, ascended so high, so fast, it unexpectedly breached the frontier of outer space. This was Flight 90, a mission that propelled a test plane and its pilot beyond Earth's atmosphere, an accidental spaceflight etching itself into history. It was a moment that redefined the boundaries of an airplane, compelling a question: how did a test flight find itself among the stars? The X-15 program was conceived to shatter limits, bridging atmospheric flight and the burgeoning reality of space travel. A joint venture of NASA and the U.S. Air Force in the 1960s, the X-15 was no ordinary aircraft. Unlike the capsules of Mercury or Vostok, it was a sleek, black, winged rocket, piloted by elite test aviators, one of whom would inadvertently become an astronaut. Its missions were foundational, paving the way for humanity's journey skyward. We delve into the mechanics of this extraordinary machine, the record-setting flights that culminated in the pivotal Flight 90, and how an unscheduled journey to space became an aviation legend. The X-15 emerged from the X series of experimental aircraft, a lineage dedicated to exploring uncharted flight regimes, following in the wake of icons like Chuck Yeager's sound barrier-breaking X-1. By the late 1950s, America sought a vehicle to master hypersonic speeds and near-space conditions. North American Aviation delivered the X-15, a 15-meter-long, 15-metric-ton, when fueled, hypersonic rocket plane. Its stubby trapezoidal wings and large wedge-shaped tail were engineered for stability at unfathomable speeds. It was, in essence, more missile than airplane, powered by a single XLR-99 rocket engine, unleashing up to 70,000 pounds of thrust. This behemoth consumed liquid oxygen and anhydrous ammonia, granting a mere 1 to 2 minutes of powered flight, enough to achieve Mach 6 and kiss the edge of space. The X-15 couldn't launch conventionally. It was borne aloft, nestled under the wing of a modified Boeing B-52 bomber, to an altitude of 45,000 feet before being unleashed. Piloting the X-15 was a singular challenge. At lower altitudes, it responded like an exceptionally fast jet, utilizing conventional aerodynamic controls. But as it pierced the thinning atmosphere, these surfaces grew ineffective. For high-altitude maneuvering, the X-15 relied on a dozen small hydrogen peroxide thrusters, transitioning its pilot from aviator to astronaut. The cockpit, necessarily pressurized, and the pilots, encased in bulky silver pressure suits akin to early astronaut gear, were lifelines against the instantly fatal vacuum that loomed at its operational altitudes. Every component of the X-15 was forged for extremes. Its Inconel X alloy skin, coated in heat-resistant material, was designed to withstand the searing friction of re-entry, parts of the aircraft glowing cherry red. Landings were unpowered glides onto dry lake beds, the X-15 skidding to a halt on fixed skids, no conventional wheels for this rocket. Each flight, though typically lasting only 10 to 12 minutes, was a data-rich exploration into how structures, engines, and pilots endured conditions far beyond normal flight, effectively creating the world's first piloted spaceplane. Between 1959 and 1968, 3 X-15s undertook 199 test missions, relentlessly expanding the known envelope of flight. The program demolished aviation records, the first winged craft to Mach 4, Mach 5, and Mach 6. It soared to unprecedented altitudes, routinely exceeding 30 kilometers. In July 1962, Air Force pilot Robert White took an X-15 to 95.9 kilometers, earning the first astronaut wings for a plane flight under U.S. Air Force criteria, which defined space beginning at 50 miles, approximately 80 kilometers. 8 of the 12 X-15 pilots would eventually earn this distinction. While not orbital, these missions were regarded by NASA as critical spaceflight research. Indeed, NASA's first crewed mission after its formation was not a Mercury or Gemini launch, but X-15 Flight 9 in 1960, piloted by Joe Walker. Years before the space shuttle, this rocket plane demonstrated that a winged vehicle could touch space and return, gathering indispensable data on hypersonic aerodynamics, re-entry heating, and flight controls. These achievements served clear objectives to comprehend flight at the threshold of space. How fast, how high could an aircraft fly? What were the physiological and mechanical tolls? Each mission carried scientific instruments, recording temperatures, pressures, and radiation. By the early 1960s, with speed records beyond Mach 6 and altitudes exceeding 90 kilometers, the next logical target was the 100-kilometer Kármán line, the internationally recognized boundary of space. This became the focus of two ambitious missions in 1963, including the celebrated Flight 90. In 1963, a bold two-flight strategy was devised to push the X-15 beyond the Kármán line. Calculations suggested the aircraft might even reach 120 kilometers at full throttle, but the risks were immense. Flight 90 would aim for just over 96 kilometers. Success would greenlight Flight 91 for an approximate 110-kilometer attempt. NASA's chief test pilot, Joseph A. Walker, seasoned NASA test pilot with 23 X-15 flights already under his belt, was selected. Calm and meticulous, the 42-year-old Walker was deemed the ideal pilot for this audacious ascent. Flight 90's prime objective was deceptively simple: touch space, return safely. The plan involved an 83 to 84-second engine burn, projected to lift Walker to roughly 96 kilometers. Onboard experiments included deploying a small, tethered balloon to measure high-altitude air density, an ultraviolet photometer to scan the horizon for UV radiation and Earth background light, and an infrared sensor to study the X-15's rocket exhaust plume in vacuum. This was no mere record attempt. It was a meticulously orchestrated research mission. Reaching or exceeding 100 kilometers would yield invaluable data on the near-space environment and showcase the X-15's ultimate capabilities. Yet every engineer knew the margins were razor-thin. Each extra second of burn, each fractional degree of climb would be critical. July 19, 1963, launch day. Around 10:20 a.m. Pacific time, high above a Nevada dry lake, X-15 No. 3 hung beneath its B-52 mothership. Joe Walker, sealed in his pressure suit, ran final checks. The B-52, callsign Balls 8, reached the 45,000-foot drop zone. Release. Walker ignited the XLR-99. 60,000 pounds of thrust erupted, propelling the X-15 skyward at a 45-degree angle. Acceleration pressed Walker into his seat. Mach 1, then Mach 2, fell away rapidly. The sky outside darkened from blue to black. The flight plan dictated an engine cutoff between 83 and 84 seconds. But reality outstripped intention. The X-15's engine delivered slightly more thrust that day. The thin air offered marginally less drag. Walker maintained a nose attitude about half a degree to 1 degree steeper than intended. These subtle deviations compounded. The XLR-99 burned for approximately 84.5 seconds to propellant depletion, giving the aircraft an extra surge of speed. Flight 90 didn't just meet its target, it shattered it. Instead of peaking near 96 kilometers, the X-15 soared to 347,800 feet, roughly 105.7 kilometers. The altitude predictor in Walker's cockpit spun off scale. For a fleeting period, the X-15 was undeniably in space, well beyond the Kármán line. Walker witnessed the profound blackness above and Earth's distinct curvature below, a delicate blue atmospheric band hugging the horizon, a vista previously reserved for astronauts. Coasting in an arc, he experienced several minutes of weightlessness. He had become the first civilian to pilot an aircraft into space. Gravity soon reclaimed the X-15. Walker pitched the nose for re-entry, the G-forces building, peaking around 5 to 6 Gs as the stubby wings bit into the thickening air and friction heated the airframe. The re-entry was nominal. Aerodynamic controls gradually regained authority below 30 kilometers. After the fiery descent, the X-15 glided towards Rogers Dry Lake at Edwards Air Force Base, touching down on the desert floor after 11 minutes and 24 seconds. A grinning Walker emerged. Flight 90 was a spectacular overshoot in the best possible sense. Post-flight analysis confirmed the X-15 had achieved Mach 5.5 on ascent and surpassed its planned altitude by over 30,000 feet. A minor setback. The balloon experiment malfunctioned, but the UV and IR sensors gathered valuable data. Crucially, the aircraft performed flawlessly in vacuum and during re-entry. Walker, an inadvertent space pioneer, had flown a winged vehicle into space, proving the X-15 could straddle two realms. Mere weeks later, on August 22, 1963, The team aimed to repeat the feat, this time with deliberate intent. Flight 91 would be Joe Walker's 25th and final X-15 mission. The objective, set an enduring altitude record, targeting approximately 109 kilometers, leaving a safety margin below the X-15's predicted absolute ceiling of 122 kilometers. Walker would again pilot X-15 number 3. At 10:05 a.m., Flight 91 launched. Walker ignited the engine, carrying a special ultraviolet camera to observe the rocket exhaust. A new altitude predictor aided his ascent. The plan called for an 84.5-second burn. Climbing steeply, the engine once again ran to depletion, flaming out at 80.8 seconds, slightly longer than planned, consuming every last drop of fuel. At burnout, the X-15 was already at 53.6 kilometers, traveling at Mach 5.58. It then coasted upward for 2 minutes in 0G. The X-15 peaked at 354,200 feet, approximately 107.9 kilometers. Just shy of the 109-kilometer goal, but firmly in space, Walker was now the first person to enter space twice in a winged vehicle, the X-15 effectively a 2-time reusable spaceplane. At apogee, he oriented the aircraft for re-entry. The descent subjected him to up to 7 geese. A roll control thruster briefly malfunctioned during ascent, but Walker compensated adeptly. After a blistering re-entry, he glided to a smooth landing at Rogers Dry Lake, 11 minutes and 8 seconds after launch. Flight 91 became the X-15 program's highest official flight. Its altitude record for a crewed winged aircraft would stand for 41 years. Its speed record of Mach 6.7, achieved on a later flight, remains unbeaten for a crewed aircraft. Tragically, Joe Walker's story ended just 3 years later. In 1966, while flying an F-104 chase plane, he was killed in a mid-air collision with an experimental XB-70 bomber. The man who had twice touched space was lost in a conventional aircraft accident. His legacy, however, including contributions to the Lunar Landing Research Vehicle, endures. He remains the first civilian to pilot a vehicle into space. The X-15 program continued until 1968, undertaking 108 more missions. None surpassed Walker's Kármán line crossings, though several exceeded the 50-mile astronaut threshold. 5 more pilots, Joe Engle, Pete Knight, Robert Rushworth, John McKay, and Mike Adams, earned astronaut wings in the X-15. The program was not without further tragedy. In November 1967, Michael Adams perished when his X-15 broke apart during re-entry from an 81-kilometer flight. He was posthumously awarded astronaut wings. The final X-15 flight occurred in October 1968. NASA's focus shifted to Apollo and the nascent Space Shuttle. 2 of the 3 X-15s survived, now museum exhibits. For over 4 decades, no rocket-powered aircraft flew higher or faster until Spaceship One in 2004. The X-15 program yielded a wealth of data crucial for later aerospace endeavors, directly influencing space shuttle design. Pilots perfected transitions between reaction-controlled jets and aerodynamic surfaces, proving winged spacecraft could navigate re-entry and land. Energy management, chase plane protocols, all refined with the X-15, the first truly reusable space vehicle. It demonstrated that a plane could reach space. Flight 90, the plane that accidentally flew into space, stands as a monument to human curiosity. An ambitious test flight became an unplanned space mission, an accidental breakthrough. Joe Walker's journey past the Kármán line demonstrated that the boundary of space was not an insurmountable barrier, but a frontier reachable even by a winged aircraft. This 1960s endeavor irrevocably altered our perception of space access. It wasn't solely about capsules atop massive rockets. Pilots in rocket planes could skim the void and glide home. The sheer audacity of a pilot finding his aircraft had become a spaceship, the sky blackening, Earth's curve unfurling below, still resonates. It happened decades ago, forged from steel, slide rules, courage, and intellect. The X-15's influence is pervasive. From the space shuttle to modern commercial suborbital vehicles, all inherit lessons from its pioneering spirit. It taught us hypersonic flight, re-entry design, and the viability of reusable space vehicles. Perhaps Flight 90's most profound lesson concerns the unexpected. By daring to push limits, the X-15 team made history, reminding us that as we continue to innovate, the boundary between air and space is ever shifting. The magic of Flight 90 endures. The little plane that breached the heavens and in doing so, illuminated a pathway to the stars,